pretty much have the exact same role as him, just with a different customer list. So we're really excited to have this partnership with Netrix and to help our education customers on their digital transformation and adopting the cloud. And today we're going to be talking about application development in Azure, as this is a very hot topic we're seeing around the EDU space. I'll go ahead and hand things off to the Netrix team, but if you have any questions, feel free to put them in the chat window or just email me directly. I'll put my email address in the chat window as well. Simon, I believe, is going to be out of the country and slow to respond to emails, so I'll be a point of contact here as well while he's out.
Great. I'll jump right in. Welcome to the Azure 123 webinar series. Today we'll be talking about developing new capabilities with cloud app development and some of the different aspects around that. My name is Joe Workman. I'm a solutions architect here at Netrix. I do a wide variety of development from the cloud across a variety of different technologies and a wide variety of different client domains. So some of the things we're going to be talking about today are, first, why should we be using the cloud to build applications? Some of the kind of lift shift scenarios to get you quickly started from your on-premise virtual machine world into the cloud as you kind of transition to actual cloud-based development. This is kind of a easy way to get you started. We'll jump into some of the microservices and Azure Service Fabric pieces that some of the teams here at Netrix have been using and the benefits to that type of architecture and why you should take that approach. We'll talk about a little bit of the different data service options that are available in Azure, and then at the end we'll talk through some of the different DevOps solutions and kind of what the teams here are using in order to kind of streamline your development process as it relates to cloud development and deployment. So the first thing we want to kind of cover is why should we make this move to the cloud? What benefit are we going to have by building applications that don't live on-premise anymore and kind of have different availability to them? And one of the first reasons is kind of scale. As we go through different applications, a lot of your environments don't need to be up and running 24 hours a day, 7 days a week. You might have different inactivity periods where you want your services to be on or off and to be able to save the money from having them running at all times. Other instances where you might have a very quickly growing application where when you first get started, you don't have a lot of people using your system or you don't have a lot of people using it concurrently. The cloud can offer a lot of options in order to scale as you need to and quickly grow without having to worry about that kind of on-premise demand where you might need new hardware because you outgrow your current capabilities. Another one is just having an availability to manage both the unpredictable bursting that some applications have where you don't know when the use case is going to increase, or also the predictable bursting where you might have an application that a lot of people check in at the end of their workday, for example, and you all of a sudden get a huge traffic spike between 5 and 7 p.m. If you know some of those options, you can have your cloud environment scale to accommodate the performance hit that is needed and scale back down so you save money in the times when you don't need that huge performance up capability. So as we jump into some of that, from an economic standpoint and cost savings ability, depending on your current data center and what your application portfolio looks like, there's a couple different options available to you. On the left-hand side here, you can see that just moving a single application, whether it be in your dev or test environment, to the cloud can save you between 20 and 30% of your cost if you can control the scalability and kind of shut some of that stuff down when it's not needed. In the cloud, you can set up nice schedules, and we do this a lot on my team here, that our dev and test environments don't necessarily need to be running 24/7. A lot of our time is wasted if we have our compute services and stuff in the cloud running at night when a lot of the dev team isn't in the office or isn't actively working on those pieces. So if we can scale down some of those services so that they're dormant in the time we're not using them, we can realize some of that cost savings. Where this benefit really takes effect is if you can move your entire application portfolio with dev, test, and production environments all to the cloud. You can realize even more savings across the number of applications you have, where again your dev test environment can kind of scale down and be very minimal, but you can also save a lot in your production environment if you know when to control the growth and kind of bursting of your application, so that you're not utilizing resources that you don't need until the time you actually need to use them. So as we kind of discuss some of this cloud IT strategy, there's a couple different options that we have available. So when we start to think about how we can move your physical data center out to the cloud, the initial things we can think about is kind of the infrastructure as a service, where you just take your existing VMs and move them out to the cloud and use the hardware that's available out there for a cheaper cost, and you don't have to manage the maintenance and setup of hardware locally. You can also take advantage of some of the platform as a service options, where you can be running out in SQL Azure, for example, and instead of having to manage the entire VM process and set up like that, you can take kind of one of the pre-existing platform options that kind of manages all of that VM and stuff on their own, and just says, hey, I want to use this specific platform, and set it up with your application that way. And then the third option is kind of using the software as a service, where you're kind of really doing the cloud application development so that you can stop running all of the infrastructure and everything else and really just develop your application to be built with the existing cloud Azure offerings. Some of the examples of pieces running on this is O365 and Salesforce that kind of are proven running software as a solution options that are running out in Azure right now. Power BI is another one where a lot of this technology is being used and tested by Microsoft themselves, that they don't want to just say, hey, use our products. They are testing all of their products and services by using them themselves in a wide suite of applications. So as we get into some of this, the first thing I kind of want to go over is kind of the how can I start utilizing this cloud technology and get off the ground in a very quick manner to start realizing some of the cost benefits of moving to the cloud. And that's where we kind of get with this what we call a lift and shift scenario, where we take our existing SQL Server VMs and application VMs and we just move them over to the cloud and move all, kind of archive old data and put that into Azure storage. And as we move them, that next step is to then take all of those and kind of utilize the Azure solutions to kind of take our existing Microsoft SQL Server after we've realized the cost of moving a VM. Maybe now we can transport that into an Azure Microsoft Azure App Service, so that we don't have to manage those VM images and everything else. And so there's some nice tools available. One's called the Azure App Service Migration Assistant that allows taking kind of these existing SQL Server or IaaS web app based applications and moving them over into Microsoft Azure SQL and Azure Web Apps. And then if that scenario doesn't fit any of the existing templates that are available in Azure, we can also set up the cloud services with the virtual machine to basically install any other dependencies that are needed. But right now there exists in Azure Cloud Services a wide variety of kind of pre-built flavors of application requirements that say, okay, I need a dependency on MySQL and I need a dependency on this. And a lot of those common templates already exist where you can kind of just import your existing application into a Azure web app. So kind of a full scenario. This is kind of one of the things that my team has been doing a lot of when we do our development, is kind of setting up our full dev and test environments in Azure. So we use Visual Studio Team Services, and as developers are working on code and checking in new features, those kind of get checked in. It automatically runs a build using the release management and build tools in Visual Studio Team Services. And then we have different branch policies where if we have a dev or test branch that's currently being worked on, any changes to that automatically get deployed out to our dev environment out in Azure. And the developers can see those, do any testing and QA on that, and then as things are ready for a new production release, we merge that branch into our master branch environment. It again gets built with any new production build configurations, gets deployed out to the staging environment out in Azure, and we have something called hot swap where that same staging environment can essentially by triggering a swap, once all of the smoke tests and everything validate that your deployment worked, it will do kind of a swap in place with the production environment, which is completely seamless and transparent to your end users. So they'll get the new features without any downtime, and if for some reason something went wrong, it's very easy to revert to that last production deploy and swap right back between the staging and production environments. So the next piece we're going to kind of get into is the microservice architecture and Azure Service Fabric. So some of you may have heard of microservices, and if not, we're going to kind of get into a little bit of what microservices are and why to take a microservice approach to your application development. And one of the main reasons between this is that it allows a very quick iteration cycle so that you can get faster delivery of features and respond to any of your changing requirements and ever-evolving applications. So this is really important when you don't really know what parts of your application need to scale. And as we go into kind of the old approach to this, which is what's called the monolithic application approach, all of your functionality is kind of in a single application. It gets deployed to a server. As you need to scale and grow your application to additional users or add new functionality, you need to spin up additional copies of that application and essentially create multiple servers or VMs so that you can load balance your performance and usability. Instead of taking that approach, in the microservice application approach, all of the different functionality is separated into smaller pieces that we call services. So you might have a user service that is strictly is in control of your user settings and user information. You might have another that is specifically dealing with routing. You might have another microservice that is just handling database reads and writes. And all of these different little microservices can be developed independently and then are deployed across a VM or Service Fabric farm, which allows all of these tiny pieces to scale independently. So if for example, you know as your application that you don't make a lot of changes to your users, you might only need one or two user services for redundancy. But if you know that you're going to have a lot of hits on your website at a certain time of day, you might need 4 or 5 of your routing services. If we look at the monolithic approach, that would mean that because you need 4 or 5 routers, you would need to spin up 4 or 5 VMs and have all of the additional processing power being unused of your user service and your database service and all of those other pieces of your application. If instead, in the microservice approach, you could take all of those different services and instead they only live on 2 or 3 VMs instead of needing multiple, you could have 6 or 7 instances of your routing service split across 2 or 3 VMs so that you can actually take advantage of the full processing capability of the machine that you're running. So that kind of gets us into the next stage that a lot of questions always come up of, if all of these pieces are separate, how do you manage the state of an application? How do you control the data and how the information is passed along? In a monolithic application, you would have a single database, you'd have different tiers of technology. As you go through, you'd probably have your web application. Behind that, you might have a server that integrates with some sort of cache, and then has another database layer that actually is responsible for the reading and writing of data that kind of controls all of the flow of your information up to the application. Instead, in the microservice approach on the right here, you can kind of see a graph of the different interconnected microservices and where state would kind of be presented. Typically in the API type of calls, you aren't caring about state. So all it cares about is getting information from a database and routing it on to the website to be displayed by your visual UI. So it doesn't care that once it makes its web call, it doesn't need to stay in existence anymore. And so that's kind of what we call a stateless service, where it's an on-demand service that as you get a request, it spins up an instance of itself, makes a call to the stateful database service, gets its information, passes it along to the user, and then can spin back down and disappear. And this approach allows us to kind of have on-demand access to different resources and scale based on usability of different pieces. So each of these services, you could have your entire server API spread across multiple different services that are all independent. That, say you have an API for getting course data for your teachers to access, that could be its own little service, and you could have another one that is course scheduling for the students can access, and both of those, based on demand, can scale independently. So Microsoft has developed a very nice wrapper around this entire microservice architecture called Azure Service Fabric. So instead of having to control when services start, the life cycle, the replication, and scale manually, Azure Service Fabric kind of handles that all under the scenes for you. And it's a distributed platform that they currently have both in Azure. It can also be downloaded as a full Service Fabric package and run on a private cloud, or uploaded as a VM runtime to other cloud um, operations, options as well. The Azure Service Fabric actually is powering a lot of existing Microsoft services today. Azure SQL Database, DocumentDB, Cortana, Power BI, Skype for Business, and many other Azure services are currently all running in the same exact Azure Service Fabric instance and client that you can develop against yourself. So in Service Fabric, comparing that to the old approach in Azure Cloud Services, typically you would have web and worker roles based on your use case for your application of going back to kind of the course management example. You might have a web role previously that simply displays all of your information. It fields data from the database, returns it to the user, lets them see the information. And then you might have another couple worker roles that actually processes information, whether it be calculating schedules or creating new courses in the database for users to access. And in kind of the old cloud services approach, you would have one instance running per VM, and as you need to scale, you would create additional VMs for each role as you need to do that. The problem with that is that as you need to scale, either for redundancy so that you always have multiples of a service running, you're not taking advantage of your full capability of the VM. On average, a lot of cloud services are rarely hitting 10% utilization of the CPU power of a VM that you have running. So instead, in Azure Service Fabric, because all of these small little microservices can be spun up and handled by the Service Fabric wrapper, it will deploy each little service in a container to the VM pool, which is Service Cluster or Service Fabric cluster, and evenly utilize the processing power of those VMs available. So because of this, you have to have less machines running. You're getting better utilization rates of the processing power that you're paying for, and you're not wasting money on additional resources that you're not using. So as we go through kind of the different options here, basically going to talk next about some of the data services that are available in Azure. So as you can see here, the SQL Server you can run in a VM just by deploying your existing architecture, taking that's kind of that lift shift scenario that we have where you take SQL Server, it's running on a VM that you manage. You can control the update process and all of that. There's also SQL itself in Azure, which gets rid of kind of the VM management part of that. It's automatically updated, managed as a service, scales automatically, and kind of get all the benefit and flexibility of the cloud. Cosmos DB is kind of something that we've started working a bit with here at Netrix as well. It's very similar, but it's the schema-free JSON type data store. It's kind of a mix between if you were planning on using table or blob storage in Azure instead, with kind of the arbitrary data formats and having that accessibility and kind of freedom, schema-free option, but having again the queryable, scalable option with a nice document database option as well. So one of the things we're going to talk about next is to kind of just show that Microsoft still has a continuous both private and public cloud offering. We're going to be kind of talking about the relational database part, which is the platform as a service, which is Azure SQL. So Microsoft Azure SQL database right now kind of extends all of the existing SQL Server capabilities into the cloud by managing all of the relational database services itself. And instead of having to control the update process and hardware and requirements, all of that is kind of rolled up and controlled for you now as a service, so that in terms of management and redundancy, when you deploy a Azure SQL database, you can be guaranteed to have kind of that redundant backup. That data is being, there's options to have geolocated information so that it's not just living in a single data center, to essentially have multiple points of failure so that you can guarantee that your data is secure and backed up and readily available. So as we go through kind of that, the other piece to kind of note on is the SQL infrastructure as a service, which is kind of just running any of your existing SQL products on a cloud VM that's kind of already been provisioned and set up with this kind of SQL Server focus. So there's currently support for SQL Server, Oracle, and MySQL for different ready-to-go VM images. You can kind of go into the Azure portal, you go through and select one of the options, and it has a drop-down of the different VM images that are currently available. So it will basically, if you choose one of those, it will come with all the dependencies pre-installed. You can select the size of storage that's attached to that so that you can do any of your backups or storing of data there as well. So essentially you get all the current power of having a VM that's managed yourself, but having a lot of the updates to the VM and the server side of things handled automatically by Microsoft and Azure. So one of the newer offerings that has been offered by Microsoft now is kind of their Azure Data Warehouse, which takes the full relational data kind of pipeline and offers it as a full service. So instead of having to kind of set up all of these additional pieces yourself, it's kind of the first elastic cloud data warehouse that hooks together Azure SQL database with Hadoop clusters, machine learning, and Power BI, all wrapped up into one as a service, so that depending on any of your small to large data needs, all of that can be handled by Microsoft in a quick, easy to deploy solution without having to kind of manage all of these different servers and services and the integration points and connections between them. So next we're going to kind of jump into some of the DevOps talk and kind of go through what my team has been doing when it comes to both a continuous deployment and integration standpoint and DevOps related topics. So the question I get all the time when talking with clients about, kind of what is DevOps and what is the benefit that we're getting when we talk about DevOps. And some people say, it's just a job title, it's automation, it is different ways for it's just a buzzword. But what I've kind of realized and tell people is that it's more a concept that it is kind of a way of making faster, more reliable deployments and maintenance of your application. And it's also kind of the tooling around that helps you maintain and manage your software. So today we're going to talk about kind of how application lifecycle is changing and take a look at kind of the next wave of DevOps tooling that kind of increases the value for our customers. So kind of as we walk through this, DevOps is much more of a philosophical movement. There aren't a full precise collections of practices of, you have to do this in these steps and this is exactly what DevOps is going to be, because it's going to change based on your current development environment and kind of your current life cycle. And as you progress, your DevOps solution kind of builds over time to get better and better in a similar way to how we develop applications with an agile approach, that you review and you grow as this model develops. So when we have this DevOps conversation, there's kind of three main pieces that we want to focus on, and that's the people, the process, and the tools. So from a people perspective, we're trying to collaborate more, focus on kind of that improvement cycle and always growing as a team. From a process standpoint, we want to increase the efficiency. We want to try to automate things as much as possible. We want to be able to streamline our feedback so that the value that we're giving to the customer can be increased both in efficiency and kind of give that faster value so that they realize their investment faster. And then from a tools perspective, we want to use tools that enhance productivity and enable collaboration between the team. One of the biggest tools that we've been using has been kind of the release management options from Visual Studio Team Services. And as we get into some of these dev habits, we will see kind of how these pieces fit in together. This slide has a lot of information on it, but the main pieces that I want to kind of focus on are the managed technical debt pieces, and we see a lot of this with Visual Studio Team Services. A lot of our automated testing and code reviews come through this pipeline. So during our development, we'll have a list of stories that we're trying to get accomplished. As soon as one developer is completed with a feature, it will automatically create a code review for the rest of the team that when they log in and see on their dashboard, they'll see a code review waiting. They'll go through, make any comments that they want. As soon as that review gets approved, it automatically kicks off a new build by merging that development branch into our test branch. All of our automated tests get kicked off, and then the continuous deployment and release management pieces will automatically deploy that test build to our test environment and kick off a message to our QA resources saying that, hey, there's a new build available. It includes the feature, this list of features that were developed and are ready for testing. And so we kind of have that iterative cycle then, that as any feedback or bugs would get added by QA, new stories get added to the backlog. They get prioritized by our product owner, taken down, and kind of that entire cycle repeats itself. So from a kind of continuous delivery standpoint, this is where a lot of our practices have the direction they've kind of gone, in that we can always see, the continuous monitoring of our build environment. So if a build fails for any reason, we're instantly notified. The development cycle can kind of rapidly respond to any of those issues, because all of our tests and build information is all readily available in Visual Studio Team Services. So some of the benefits of kind of these DevOps options is kind of, we can deploy code faster, we can have fewer failures because we have automated tests and continuous deployment running, and kind of a lot of the digging into issues is minimized when you can reliably have code that's automatically getting deployed. A lot of times when we first start a new project, this continuous deployment piece is one of the very first things we tackle, because we have a large team of developers that if they all have to individually manage, deploying their new features out to the server, they would have a lot of wasted time in, setting up their deployment pipeline and everything else, that if we can do this once at the beginning, it just speeds up our entire development iteration cycle as the project progresses. So that kind of gets to the DevOps cycle that I briefly mentioned earlier, that developers will implement a feature, check that into our code repository, it gets reviewed, the build gets kicked off, all the automated tests are run. If all of those tests pass, it gets deployed out to the cloud application. It gets monitored using tools like Application Insights and Power BI, and any feedback is given directly back to the development team to kind of monitor and improve the application, and then that cycle kind of repeats itself to allow you to kind of have that iterative design and development process. So how those tools kind of connect to the Microsoft ecosystem from a development standpoint, using Visual Studio Online and local developer workstations, they kind of develop code, get that checked in, and collaborate using Visual Studio Team Services and TFS or Git. Those kind of get the development process started. Then from a build and test perspective, you kind of have your build and continuous integration using release management in Visual Studio Online and Visual Studio Team Services. All of that kind of runs through your automatic build and test setups, and then goes into kind of the release management part, which is step 3 in the deployment. That release management allows you to set up different hooks for whether it be different branches in your repository or different applications in the same branch that get deployed to different cloud servers. All of that kind of happens automatically. You can also set up gated deployment. So right now in our dev environment, for example, all of that gets deployed as soon as the automated build tests pass. But for our staging environment, that requires a sign-off from the QA resource that says, hey, I ran all of these additional tests and verify that these features are passing their acceptance criteria. And then those can get basically there's a list of people that need to sign off to say deploy to this staging environment, and that is the QA lead, the development team lead, and the product owner will basically sign off on their notification that they get by email to say, hey, I approve this deploy to staging. It will get deployed there. As soon as it's ready, then when you want to release a new feature to the customer, you can do the hot swap from within our deployment area, and those releases then all get tracked in the release management to have saved versions of basically your history of different deployments. And then once we have the code running out in production, You can use Application Insights is a great tool to kind of collect usage information, everything from page views to button clicks to error handling and reporting. All of that can kind of get collected in your application and then reviewed in the Application Insights portal or exported to tools like Power BI to kind of dive deeper into both how your users are using your application and any issues they might be running into as your application is out there running. So I know we ran through a lot of information in a short amount of time. So we're now going to open up the field to questions. I think Lane's been kind of fielding some questions as we've been going through. So.
So I haven't seen any questions in the chat window. We can field some questions. If you guys have any, you can take yourself off mute or put them in the chat window. We'd be happy to answer them. Okay. Well, if any of you guys do have questions, my email address is in the chat window. You can reach out to me directly. Just so you do know, there are some upcoming sessions that we have. So stay tuned for those. It's going to be next week at the same time. We're going to be going over cloud security. Security is definitely a big topic that we get a lot of questions about, so that'll be a really good one to attend. If you've missed any of the previous webinars, you can find them on demand. We'll also be emailing out a on-demand copy of this session if there's anything you want to go over again. So that follow-up email will be sent out shortly.
Well, thank you everyone for your time today. Like Lane said, if there's any questions, feel free to reach out and we will be able to get you answers and more information on those.
Yep, thanks everybody for attending. And then if you do want to get started with any of this stuff, you can always reach out to your reseller in regards to adding a minimum monetary commitment to your EES or OVS ES agreements. The minimum commitment is about $100 a month. That can be prorated depending on where you are in your agreement cycle. And it's a really good kind of investment to get some training opportunities where you can actually do sessions with folks like Netrix here, where they'll teach you how to create VMs in the cloud or virtual networks and stuff like that. So there's some good action items that you can take from this as well if you're interested. All right, thanks everybody, and I'll go ahead and close it out there.